This is chapter 8.2, exercises 31 through 40. This section 8.2 in our book has to do with ellipses. And we're going to go over these odd number problems from 31 through 40. And in exercise 31 through 36, find an equation in standard form for the ellipse that satisfies the given conditions. Now, in the exercise set, it includes 21 through 30 in our previous video lesson. We were looking at ellipses that were centered about the origin, 0, 0. Now, for these exercises, we're looking at an ellipse center not at the origin. So let's quickly review the standard form and equation for an ellipse. And that's going to be x minus h, and that's going to be quantity x minus h squared over a squared plus, we have quantity y minus k, and that's going to be squared over b squared equals 1. Now a is defined as our semi-major axis. So that's going to be 1/2 of the major axis or longest axis, and B is defined to be the semi-minor axis. And this would be the case for a horizontally oriented ellipse. Now, if you have a vertically oriented ellipse, these A and B's are going to switch, and so in a vertically oriented ellipse, the semi-major axis will be related to the y term. And this, as far as this h, it's a quantity x minus h, and so h is the number that determines the left or right shift of the ellipse, and also this k that's associated with the y reflects the up or down shift from the center. So let's go ahead and make a graph of this and see what's happening. So we have an XY coordinate plane right here that I've drawn. So we have X and Y. And we have major axes endpoints at 1, -4. So that's going to be 1 to the right and 4 down. 1, 2, 3, 4. And so that's going to be this point right here. And then 1, 8 is our other endpoint. So that's going to be 1 to the right and up 1, 2, 3, 4, 5, 6, 7, 8. So right up here, I'm going to mark 1, 8. So I got 1, 8 up here, and down here I got 1, -4. Now to find the center of this ellipse, that's going to be the halfway point between these y coordinates of 8 and -4. So we'll say 8 minus 4 over 2, which is going to be 4 over 2, which equals 2. And so our center of our ellipse is going to be here at the point 1, 2. And that's going to have a bearing on what our equation is. And as far as the minor axis length, well, the semi-minor axis length that's going to be our minor axis length divided by 2, which is equal to 4. So we're going to go 4 to the right and 4 to the left. So 1, 2, 3, 4. We have this point here. And then our other endpoint of the minor axis is going to be 4 to the left, 1, 2, 3, 4, so right here. So this is going to define our ellipse, and just sketching this out in red, that looks purple. So there we go, this. So that's going to be our ellipse. And now we can write the formula for this, which is going to be x, and we shifted 1 unit to the right, so that's going to be -1, because for h to be, when h is positive, that's going to be minus something. So we have that quantity squared over our semi-major axis, where our semi-major axis we can see is halfway between 8 and 4, 8 and -4. So we have 8 minus -4. That's going to be our major axis, and our semi-major axis is 1/2 of that, or 6. So we're going to have, well, what's going to happen, my friends, is this. Let me go ahead and put the y in. Okay, we went up 2, so that's going to be -2 squared. Now in this case, our major axis is related to the y because we have a vertically oriented ellipse. And so we're going to put 6 squared, or 36, down here below the y term. And our semi-minor axis length is 4, and 4 squared is 16. So in this case, we have it switched where our a squared is underneath our y term. So this is going to be our equation in standard form of this ellipse. The next on our problem, which is 33, in this case we're given that the foci is 1, -4, and 5, -4. Our major axis endpoints are 0, -4, and 6, -4. So let's go ahead and just sketch out what this looks like. We've got our xy coordinate plane here, xy, and foci at 1, -4. So here we go, 1 to the right, 2, 3, 4. So there we have one of our foci down here at 1, -4. And then we have our other foci here at 5, -4. So 1, 2, 3, 4, 5. And we go to -4, which is down 4, which would be right here. So here we have our foci, and we have our major axis endpoints at 0, -4. Well, 0, -4 is going to be 0, 1, and down 4. So there we have it, right on the y-axis. And 6, 4 is our other endpoint, major axis endpoint. And so we're going to be looking at a horizontally oriented ellipse, and our center is going to be halfway between these two endpoints. So the center of our ellipse is going to be at halfway between our endpoints, between 0 and 6. Well, 6 divided by 2 is equal to 3. So our x value for our center is 3, and our y value is going to be -4, because -4 is going to be right between the endpoints, between the foci. So here we have our center here at 3, -4. That's our center. So we can start writing our formula. We're going to have our center, x. Remember, we're shifting to the right, so that's going to be minus k, and k is 3, squared. And we're going to have plus y, and we shifted down, force a minus negative, so we're going to have y plus 4, which is minus negative 4 squared. And as far as our major axis, equals 6. So semi-major axis equals 6 over 2, which is 3. And a squared, or 3 squared, is going to be 9. So that's what we're looking like. And we have all this equal to 1. Now we need to find our semi-minor axis, and we'll have the problem solved. Well, the foci equation, or I'll call it the focus equation, it's c squared equals a squared minus b squared. And in this case, we have what c is, because c is 2 from the center. So c squared is going to be 2 squared, which equals 4. It's going to be equal to a squared. Well, a squared is equal to 9. And 9 minus b squared. And if we subtract 9 from both sides of this equation, we're going to have negative b squared is equal to 4 minus 9, or negative 5. So b squared is equal to 5. And so b is equal to the square root of 5. And so we can go to, that's going to be our semi-minor axis length. And if we go up square root of 5, that's going to be about 2.25. So we would mark it up 2.25 and down 2.25. So our ellipse is going to be looking like this. And as far as answering the question, our semi-minor axis is square root of 5, and so our semi-minor axis squared is going to be simply 5. So this is going to be our answer to problem number 33. You can see that the shift left to right and up and down complicates the finding of the equation. It still is doable. I find like this, sketching it out is a pretty good way to go. In this case, problem 35, major axis endpoints 3, negative 7 and 3, 3. And so we sketch out our coordinate plane again. And we have 3, negative 7, so up through over to the right 3 and down 7, 2, 3, 4, 5, 6, 7. So this is going to be one of our endpoints down here. And 3, 3, so that's going to be 3 to the right, up 3, 1, 2, 3. And so here are the endpoints marked off. And to find the center between these two endpoints, if we take our center, first of all, our major axis length, okay, is going to be 3 minus negative 7, which is equal to 10. So therefore, our semi-major axis is going to be 10 over 2, which equals 5. And so let's go ahead and find where that center is going to be located. What we do is we take this average of 3 and -7. So 3 minus 7 divided by 2 is kind of the midpoint formula. So we're going to have -4 divided by 2, which equals -2. So here at 3 comma -2 is the center of our ellipse, and so we can go ahead and start writing our equation. We're going to have x, and we went to the right, so it's going to be x minus 3 squared over what we don't know yet, plus we're going to have y. Well, we're shifted down 2 units, so it's going to be y plus 2 quantity squared, and we know our semi-major axis is 5, and 5 squared is 25. And that's equal to 1 to the right. And our minor axis length is 6, so a minor axis is going to be equal to our semi-minor axis, what we're trying to find for the equation. Semi-minor axis is our minor axis divided by 2, which is 3, and 3 squared is 9. And so just to round out the sketch, we're going to go to the left 3 and to the right 1, 2, 3. So this is what our ellipse is going to look like. Okay, and this is already kind of drew it kind of not to scale tremendously well, but well enough to see this correct answer. So this is going to be our equation, problem number 35. Okay. Next, let's go to our next problem, which is 37. Here we have find the center, vertices, and foci of the ellipse. We have the equation of this ellipse. And so what this looks like, just kind of sketching it out here. X, Y. Okay, we have x plus 1, so that's going to be x to the left 1. And y minus 2, that's going to be y is up 1. So right here, that I'm now marking in red, is our center of our ellipse. And our semi-major axis is going to be the square root of 25, which is 5. So if we go to the right, 1, 2, 3, 4, 5, there's our right endpoint. And we go to the left 5 from our ellipse center at -1, 1, 2, 3, 4, 5. And so we have our other endpoint. So this is going to be along our major axis, and so our foci are going to be along this area here. So we have our vertices and we have our center, and let's go ahead and just write those out. Center is going to be the coordinate pair -1, 2. Okay, vertices are going to be at, looks like -6, 2, and also at 1, 2, 3, 4 at 4, 2. And so really we're just left to find the foci. Well, the foci are going to be located by finding the formula for the focus, and that's going to be c² equals a² minus b². Well, in this case, c squared is going to be equal to a squared, which is 25, minus b squared, which is 16. So c squared is going to be equal to 9. So c is going to be equal to 3. And what this is, it ends up being like plus or minus 3. And we're going to explain this. So it's going to be 3 to the left and 3 to the right of our center. So that's going to be left right there. And to the right, 1, 2, 3. So we're going to have, let me put the foci here. They're going to be at 2, and it's going to be negative 1, 2, 3, 4. So negative 4.
Teachers and staff, like you are on duty this week, please report to your
and
duty stations.
2,
Please
2.
report to your duty stations. Thank you.
So that's going to be it. Okay, last one we're going to look at is under problem 39, and that's going to be, we're going to go ahead and find our kind of graph like we did for the last one. We have x, y, coordinate plane, and we're going to have y plus 3. Well, y plus 3 is going to be down. Remember, we had y minus k. So to get y plus 3, we have to have y minus negative 3. So our center is going to be located at y equals negative 3, and x equals 1, 2, 3, 4, 5, 6, 7. So at 7, comma, negative 3 is where we find our center of our ellipse. And so I'm going to put center at 7, comma, negative 3. There we have that. As far as vertices, well, our major axis is going to be located along the y because that's the bigger number. So our semi-major axis, so let me just write this to the right, semi-major axis is going to be square root of 81, which equals 9. So that means we're going to go up 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's going to be an endpoint right up here, and that's going to be at the point, let me put vertices. We have the point 7, comma, and 1, 2. This has to be 7, comma 6. It's going to be one of our vertices, and the other vertex is going to be going to 7 to the right, and then down 9 from there, down 9 from negative 3. So we got to go down 9, 2, 3, 4, 5, 6, 7, 8, 9. And so what that's going to be is, that'll be negative 3 minus 9, or negative 12. Okay, so here we go, negative 12. So that's going to be our vertices. And now for our foci. Well, our foci are going to be located along the major axis. So that's going to be at the x-coordinate of 3, comma, we don't know what yet. And then the other foci will be also at the x-coordinate of 3, and the y-coordinate we don't know yet. So we need to find this out. Well, remember the formula for foci, which is going to be c squared equals a squared minus b squared. And so c squared is going to be equal to, well, a squared is going to be 81, and minus b squared, well, b squared is 64. So that's going to be equal to 81 minus 64, 17. So c squared is equal to 17. Therefore, c is going to be equal to plus or minus 17. So what we're going to have is our foci is going to be located at 3, comma. What we're doing is we're going to take negative 3, because we're starting at negative 3. So I'm just going to put it like this. At negative 3 plus square root of 17. And then our other foci is going to be located at 3, comma, negative 3 minus square root of 17. Well, square root of 17 is just a little bit bigger than 4, so our foci are going to be located just kind of a little bit over 4 up, so right here and down. Let's see, 1, 2, 3, 4, about here. So those would be our foci, and our semi-minor axis is going to be 8. So if we go to the left 8 here, and to the right 8, oops, it'll be down here, center is here. There we go. There we go. So this is what our ellipse is going to look like. Kind of rather large ellipse relative to the other ones we've been sketching. Okay, so not tremendously to scale, but I think you get the idea. Here would be all the relevant points for what we're asked to find from this equation. Good luck on all your even number problems. My advice, make a sketch. It'll just make your life easier in figuring these things out. Good luck, and thanks for viewing.